Welcome! In this series of videos, we will cover the design and implementation of a project, from initial design through coding and development to testing, using the PowerBasic Windows compiler. Today we will continue our project to look at the use of text prediction software. This was our application at the end of the last video. We have created a dialog which allows a user to add text data to our text prediction database. They can pick one or more files, click the Open button, and these will be added to the database. At the moment, we only have a small number of files to feed our system. As we are going to be adding considerably more files to feed this system, it's a good idea to provide the user with a progress bar to indicate how long the process is going to take. So that's what we're going to do first. So let's have a look at our code. So in our list of constants, we're going to add two more objects. One for the label of the progress bar and one for the progress bar itself. And at the moment, we set the starting size of our data array at 10,000 elements. And the number of increments we make on that is going up by 1,000 elements at a time. We're going to increase these figures to allow more data to be stored. We're pushing it up to a start size of 20,000 elements, and each time this needs to be increased, we're increasing by 5,000 elements. So if we now have a look at the function which displays our dialog to the user. In here we're going to add these two new objects, a progress bar and a label. And there are our two new objects. And also in this video, we're going to be allowing our user to type into the main text box. Once two words have been typed in, we're going to do a search on the database to pick up what the most likely third word is going to be. And they're going to be sorted with the most likely word at the top of the list. So we're going to be making some changes to our list box. Currently, we have the sorting option on, so we're going to take that off. And we also have multi-column turned on. We're going to turn that one off as well. So with that in place, we'll just set the font on our label for the progress bar. So now that we have that in place, let's run the application to ensure our progress bar appears in the correct location on screen. And there is our progress bar. So we'll need to put some code into the application to update the progress bar as files are loaded. So back to the code. So if we have a look at the function which performs the processing of files, I'm going to amend that to take an extra parameter. This will be the handle of the progress bar, so that this function knows which object to update. Within this function, there are two possibilities. Either the user has picked a single file, or the user has picked multiple files. So we're going to set the range of the progress bar based on which scenario the user has selected. If the user has picked a single file to load into the system, then we're setting the progress bar's range to between 0 and 1. And we'll set the progress bar at 1 after the file has been processed. So we'll need to add in that parameter where the process files function is actually called. And having that in place, we can now try to run our application. So if we pick just a single file, and we'll see our progress bar is updating quite happily. So let's put the same change in for multiple files. As a single file loads really quickly, we hardly need a progress bar. However, once the user is loading multiple files, it will take longer to process. And this is where the progress bar becomes useful. So for multiple files, we're setting the progress bar's range from 0 to the number of files that the user has selected. In this section, we're making two changes. The first is to the status bar. Previously, we were showing the words loading file, and we've added to that to show the file number. Additionally, we're adding on the words record space and then the upper bounding of the array into which we're putting our words data. This is a good indication of how large this array is becoming. And finally, we're using a dialog redraw command to ensure the dialog is shown to the user. So let's click on Add Text Data. We'll pick 10 files and we'll click Open. So the progress bar is now showing us the indication of what's actually happening. Now it's not updating the status bar at the moment. So we obviously have a small bug in the code, so we'll look back and fix that now. If we have a look in the process file section, here is the offending line of code. We'll just comment this one out for the moment and we'll try running that again. We pick our 10 files and we click Open, and it is now showing us the space in the array. So the files are loading quite happily. Once we've accumulated a certain amount of data in the system, we'll need a nice easy way of actually reloading that the next time an application loads to save having to build it every time we run the application. So I'm going to add a new button to our toolbar that allows us to load the text data into the system. So we're going to make a small change to our toolbar include file to allow that. So in our toolbar include file, we've added a new event. This is for loading. And we've added a new icon called load icon. And when we create the toolbar, we're adding this on to the toolbar itself. So if we try running our application now, we should have the new icon on the toolbar. And there is our new icon, load training data. The purpose of this icon is to load the two files. This will be the word count, which contains the number of each of the iterations of the 3-word phrases. And the second file is worddata.txt. This contains the 3-word phrases. Now all we need to do is to put the code into our application to allow the load training data to function. So once again, back to the code. So we'll need to put a new event into our event handler, our callback function. And here is our new event, the ID load. If the button is clicked, then we're going to load the training data arrays. So we're going to create a new function called load arrays, which takes a single parameter, which will contain an error should something go wrong with loading the files. If this function returns true, then we will display data loaded. If this function returns false, then we will display an error message to the user, telling them what went wrong. So let's now create our load data arrays function. So here is the skeleton of our new load arrays function. First of all, we're going to attempt to load the word data array. We specify the location of the file in the data folder, and we have a constant for the name of the file. We're enclosing this in a try-catch block just in case an error occurs. We're opening the file from input, scanning the file for the number of records. That allows us to redimension the word array for the correct size. And then, since this is a string array, we can use the line input command on a single line to load the data that is in the file in one step into the array. And should something go wrong, we then populate the error variable with the error that occurred. And finally, we close the file. So this should allow us to load this single file. Assuming that file loads successfully, we can now attempt to load the count array. With this, we're doing almost exactly the same thing. We're specifying the file name to load, we're using a try-catch block to trap any errors that occur, and we're redimensioning the count array as the number of records in the file. For numeric arrays, you have to do a for next loop to populate each element of the array using an input command. And should an error occur, we're populating that into the error variable and passing that back to the calling function. So this should now allow us to load the data up into our array. So let's try running that now. We know there's data there, so if we click Load Training Data, it should tell us the data has been loaded. So now that we've got the data into the system, we can go on to the next stage. And this is to allow the user to type some text in here on the Type Text box and to get a list of possible words appearing in the list box. So back to the code. In order to trigger this, we need to put another event into the callback function, the event handler. And we're looking specifically at the text input, this section here. And we're putting in an en change event. This will pick up every time this text box changes. So it will trigger every time the user presses a key on the keyboard while they're inside this text box. And we're going to call a new function called processTextChange, giving it 3 parameters: the handle of the dialog, and the handle of the text box, and the handle of our list box. So let's create this new function. So here is the skeleton of our new function, processTextChange, taking the 3 parameters. As this function will trigger every time the user presses a key on the keyboard when they're inside this text box, we need to ensure that they've typed at least 2 words. So we're going to use a control-get-text command to get the text that's currently in that text box. And we're going to replace any carriage return line feeds we find within that data with a single space. Next, we're testing the rightmost character of that string. If it does not equal a space, then we will ignore until the word has been completed. So this function will only go further if the last character typed is a space. Next, we will pick up the first word and the second word. These are the last 2 words that the user has actually typed in. The parse command comes in very useful here, as using the parse command with a minus allows you to look from the right-hand side of the string going backwards. So since we're parsing on a space character, the -2 value will give you the second word. The -3 value will give you the first word. So if both the first and second word are not empty-length strings, then we can proceed. So we have 2 words, so we need to suggest a possible next word. So we're going to populate a new variable, which we're going to call phrase. This will consist of the first and the second word, separated by a single space, and then tacking on to the end another space. And we're going to call a new function here called suggestWord. This new function will have the job of working out what word we want to suggest to the user. And we're passing to this new function 3 parameters: the handle of the dialog, the handle of the list box, and the phrase we have just built up. So here is the skeleton of this new function, suggestWord, with its 3 parameters. We're going to suggest a word based on the phrase that's been passed in, and we'll sweep through our array looking for possible matches. In this case, we may have multiple matches on the words. So before we go further, let's have a look at the words we've built up so far. If we have a look in the worddata.csv file, this is the composite file which has not only the 3 words, but how many times they actually appear. If we open this up in a spreadsheet, we will get our list. In order to have a good amount of data, I've fed the system with a large number of files. During this feeding exercise, I discovered there's a performance problem when you feed it a large number of files. The more files you feed it, the slower it becomes. We'll tackle this performance issue in the next video. But we've got enough data in this file to allow us to actually progress. If we filter our data based on the first 2 words, as in we will, there are a large number of options on we will, and you can see which ones are going to be the largest. So if we do a sort based on the count, we will see which ones are likely to appear at the top of our list. So we have we will look at the very top, closely followed by we will see, and we get a decreasing number going down the list. As this is a fairly common phrase, we want to display a limited number of these to the user. So we're going to set the system so that it displays 10 values to the user from which they can select. So we'll keep this spreadsheet open. We can refer back to it to ensure that our search process is actually pulling back the correct data. As spreadsheets are very good at locking files, we will have no issue with our application because this CSV file is not actually used by the application. We use the two text files. So let's first of all have a look to see how we can pull information out of our array. As I said, we're going to be displaying 10 words to the user to select. We'll set this limit in a constant at the beginning of the application. And there is our maximum number of suggested words constant, set to be 10. So we're going to set up a couple of additional variables here, one called start and one called end. These will specify the start and end positions to scan in our array. And we will set the start value initially to 1, and the length of the phrase is going to be used for the end value. The purpose of this is to allow us to identify the word we want to look for. We are looking for the words "we will" followed by a space. We don't want anything else that's going to appear in there, so we're searching for this number of characters. And we're dimensioning two new arrays. These arrays are going to hold the results of our search. And we're going to be using the array scan command. This to scan the data that's held in the word data array. We're using the from command to ensure that we're only testing the first few characters of the data in each of the elements. So we're looking for "we will", we're looking for just the "we will" and the space after it. We're collating it to uppercase to ensure we're doing a case-independent search. And should we find a value, we're passing that to a variable called match. If the match variable comes back with a 0 value, then we have found no matches at all. If it returns a number other than 0, then we have found a match. So if we have no matches, we exit the function immediately. Otherwise, we can display to the user our first match. So our first task in here is to clean out our list box using the listbox reset command. Now we need to add our first result to our array. We can get the word out of our data array by using the parse command and looking for the last element held within there. We can pull out the word count to know how many this actually is, and we need to actually store that information in our array. But just to prove the logic so far is actually working, let's put a bit of code in here just to display this on our list box. So for the moment, we will comment out these two lines of code, and we will put in a command to add it straight away to the list box. So if we run the application now, we'll load our training data, and the data is loaded. And to test this out, we will type in the words "we will" and a space. And as soon as we hit the space bar, we get the word "look" coming out. Now this just so happens to be the highest one on the list. In this case, that's because it's the first one in the file of all the ones we can actually see. So we've proved the logic to search our array is actually working. We now need to push on, and we'll create this new function to allow us to add to the word data. So here is the skeleton of our add to the word data, taking 4 parameters. The word that we wish to add, the number of iterations of that word, and the 2 arrays. These are our result arrays, which are only 10 elements in size. So first of all, we need to check to see whether the array has already been filled. Possibly we already have 10 values. And we're testing whether the number within that array is larger or equal to the word count for the current word. If that's the case, then the array is full and this word count is not greater. Therefore, we ignore it. Otherwise, we need to step through each of the 10 elements in our arrays to check to see if the current slot has a greater value. If the current slot has a greater value than the current value coming in, then we iterate our loop. So we're only wanting to add the value to our result array if the number of iterations of that word are greater than the value already stored. So we're testing for an empty slot. If it's an empty slot, we will store the value. If it is not an empty slot, then we will check the value held in the word count against the word count coming in. And we will only store this new value and word if the word count coming in is greater. And we can quite easily use the useful array insert command. This will insert the value in the array and push all the other values down by 1. And if there had been a value in the 10th element slot, it would drop off the end of the list. And then we can exit the function. So the array commands that are provided by PowerBasic are very powerful and save a great deal of coding. So now that we've added this first match to our array, we need to look for more matches. So since the match value we found is the element of the array, we're just going to add 1 to it, and we'll store that as previous match. And while the previous match is less or equal to the upper bounding of the word data array, we can then proceed. But only if the count of results we have is less than or equal to the word result. In other words, we have not yet reached the 10 results. And we can now search for another match within this while loop. We're searching for the same information, but we're only searching from the previous match value onwards. This means we will skip over everything that is before the match we just found. And again, if the match returns 0, then there are no more matches, and we can exit the loop. Otherwise, we want to record this new find. So as we did before, we will increment the count, and we will push the match onwards to the previous match -1. So this sets the array index. And using that, we can actually get the data of the word and the word count. And having got those two variables, we can then go ahead and call the function again to add the data to the word data array. And once we've done that, we can then set the previous match to be the long match +1. So once we've got to the end of this, we should have 10 values held within our results arrays. And they will already be pre-sorted, with the most prevalent word being at the top of our list. So we now need a simple for next loop to add them all to the list box. It's possible we may not actually get 10 values. Therefore, we can test the value in the word array to make sure it's not an empty length string. And if that is the case, we can safely add it to our list box. So now that we have our code in place, let's try running the application to see what we get. And we will click on the load training data to load our data. We'll bring in our spreadsheet, which is what we're testing against, and we will type in the words "we will" and hit the spacebar. Now we have what appears to be 10 results on the screen. The first word is the word look, which is the top on our list, which is ideal. Then we have the word see, which is the second on the list, but the third one on the list should be the word create, which is not on the list. We do have set next, but we have the word cover, which is further down, so we are skipping some words out of the list. So there appears to be a bug in our application. So we will need to go back to have a look at the code to see where our bug has occurred. So as it's appearing with 2 entries quite correct, there may well be a problem with the position in the file. So let's have a look where we actually do that piece of code. If we have a look at the function which does the suggesting of the word, this is running in a loop. And currently it's looking at this condition. It's looking for the match we're actually looking at being under the maximum number of elements in the array, and that the count number is less than the word result. I think this is our problem. This is limiting the result to finding 10 values. It's quite possible in our file that the 11th or above 11th value has a larger word count. So having commented this line of code out, let's try running the application once more. So there is our application. We can load our training data and we can bring in our test data. This is what we're looking to get on our screen, this 10 list. So let's type the words. So if we look at the words we've been given as a selection, we have the word look, which is the first one on the list. We then have the word see, which appears next. We then have the word create, and then we have the word set. Then the word then, and then we have two words which have the same count value, cover and declare, which we have both on the screen. We then have populate and continue, which matches on our list. And then we have the final 10th value of need. Need has a value of 4. And as we have a number of 4s on the list, it will pick whatever one comes first. So it would appear we have successfully managed to get a list of 10 possible words, which matches the data coming out of our spreadsheet. So in summary, what we've achieved today is we've amended our application to allow the loading of the training data that's previously being assembled. With this training data in our application, we can then type in 2 words to our text box. As soon as the space bar is pressed after the second word, it will then search out 10 possible words, starting with the most prevalent at the top of the list. And this matches the data we've got back from our spreadsheet. So our text prediction software appears to be working fine. What we will do in the next video is we will attempt to bulk load even more data into our system and make it more performant. However, that's it for today. Thank you for watching.